Hi, so this is video number 2. We've now completed the flexpower4 system and run a bit of commissioning on it. So let me tell a little bit more about how it works. If you look over here, well, first of all the mesh from the previous video is now nicely covered. It's still in here, but everything has been cabled. This is the DC side, so that's PV panels going to chargers. The chargers are over here. We have 4 FM100s. Each one capable of delivering 100 amperes. And because we have a rather potent array sitting down there, so each of these are tied to a string of 12 465 watt Luxor panels, and they have already, which is very typical lithium, they have already surpassed the nominal yield. I just had a reading of 6 kilowatt on one of these. They're not supposed to do that. They should be 5. But it's because we overpanel slightly, and we do that deliberately. It is no harm done. It simply means that the system will work earlier on the day. It will work through light cloud cover and later into the evening. So you have a more constant peak load capacity. So each of these should be producing about 5 kilowatt when everything is running hot. And for that reason, we have had to throttle down the regulators just a little bit, because here we have 100 amp breakers. So each of these regulators will have its corresponding breaker, and they're 100 ampere. So having 6 kilowatts suddenly running through for a little time, it will flip by itself. And if nobody's around, well, that's one array being lost. So we had to throttle down a little bit on the capacity. These are the inputs of the arrays, array 1 to 4, and they're only 60 ampere because we're obviously running FM100s, and they can run up to 300 volt line voltage. After 300 they burn, so we never touch that. But in this case, we're running at 200 volts of line voltage, which is very comfortable. So they should be very happy, our FM100s. They got lots of meat, and we kept them safe by throttling down a little bit. So that supplies, again, 4 inverters over here. So we have a master that will run at all times. You see it's turned on. Right now we had a slave turning on as well, because the load demand in the house came close to 3 kilowatt. So it will call them on accordingly from 3, 6, 9 to 12 kilowatt constant load. This is Outback equipment. It's actually built to really work. Should anything ever happen with this, which very rarely happens, we are also able to come on site and do service on site, which means you don't have downtime. You don't have to take a thing off the shelf and ship it off to a wholesaler to get service made. So we don't waste time like that. We don't like downtime. So all this is serviceable. The same thing goes for the regulators. Over here we have the AC side, so this is where we come out of the system. So we have here 4 outputs. They're all linked together in a parallel connection. That gives us the 12 kilowatt. It could also have been 3 inverters and a 3-phase system. It is not. So in this case it's a monophase 12 kilowatt capacity. It's all being backed by 5 G-cell lithium 11.7 kilowatt hour batteries. We don't call them 11.7 because what we use of them is 80%. It's very important with the lithium that we don't charge totally up nor discharge completely. So we run it in an 80% capacity. So we say that here we have 50 kilowatt hours of storage between solar cycles. And that's all interconnected via a bus bar, goes into the DC hub. And because we are in a system that is a 3-phase system really, not this, but the house, we have split the 3 phases coming into the house over 5 chargers. That's a little bit excessive normally. Each charger will give you 2 kilowatt. That's running to the lithium. The reason we have done it, so this means our client can actually draw 10 kilowatt from the grid if need be. And the reason for it is that we have a very dirty grid here. It's a very long power line. It's not been maintained well. And a voltage drop will go all the way down to 170 volts sometimes, and that causes grief in the house. So it's simply like an emergency thing. Normally we would only, maybe for this amount of batteries, we would put 2, maximum 3 charges. So you can kind of see, you can make a cleaning flow here, because everything here is only connected to grid via these transformer chargers. That means everything comes out into here, into the DC domain, and comes out Outback pure and adjustable by us, and runs to the house. We happen to be quite far away from the house, so we have deliberately put the voltage up on the output to make sure that we compensate for a voltage drop over a long line. So all in all, yeah, well then we have a little remaining sweet little thing over here. It's an old ancient Rolls S605 or S500 battery pack with a single old clapped out FlexMax, but still working as it should do, like a workhorse. And that's just to maintain these batteries. What's going to happen with it, we don't really know at the moment, but we are moving another big system up here, a radiant system, also Outback, with some very big Rolls batteries, and that's going to simplify it a little bit. So eventually we'll probably have not a three-phase system, but three singular phases supplying various places on the compound. There's 3 houses. So a main house, a bungalow, and a place under construction, you could say. So that's it. Any questions? You can definitely put them on YouTube, and I'll see if we have the time to answer. Thank you.